computing science, also called COSC. We call it here COSC. So today, your crew consisting of myself. My name is Vishnu Prasetya. I am the program coordinator of this master program, and we also have.
Hey, I'm Arjan. I'm a master student at this program, and we also have Suzanne, and she's answering your questions in the chat. She's also a master student here.
All right. So as you can see on your screen, you can also ask questions directly on the chat throughout the presentation. And Susan will be answering your questions over the chat. And at the end of the presentation, there is also a Q&A sessions where you can also ask questions during the Q&A, and we will be answering your questions. All right, so let's start with the first slide. So this is a summary of what this program is about, the main feature of this program. So firstly, it is a research-oriented master program. So what that means, I will explain it in the next slide. It is a full-time master program, 120 EC and 2 years master program. It is taught in English, international program. So it will also get an international diploma supplement. So as I said, this is a research-oriented master program. So firstly, it is a master program, so you will get a master level education, you will get a master diploma, but it's also a program that is being put together by researchers. So I'm a researcher, and many of my colleagues are, and we are passionate, we love to do research, and we would like to get you involved in our research, and so that we can go together, explore a lot of fun things and things that are state of the art in the research. So it may sound a bit strange because you may also pose question, what does it have to do with eventually your research career? We will address that later on. And because it's a research oriented master program, we have a number of research groups that are behind this master program. So Arjan, can you tell us a little bit about where do you already choose research groups to do your study?
I'm in the software technology research group, and that's because already in my bachelor's I really enjoyed the programming technology-like subjects like functional programming and languages and compilers, and the software technology research group is really focusing on these kind of things. So everything involving research around programming languages and how we can improve in that area. I find it very nice.
Okay.
Yeah.
Thank you.
Yeah.
So Arjan did research in software technology. So that's not the only research group behind this master program. We also have the 3 other research groups. So for example, we have a group that is focusing in algorithms. We also have a research group focusing in, I think, decision support system, right? Mm-hmm. And a research group that is focusing in on data. Do you know something about research on data?
I did the big data course and the data mining course. So in the data mining course, we look at how we can do classification of data. So we have some data where we use as a training set, and based on this training set of data, we try to classify new samples of data. This is, of course, really hip with all the big data going on these days. People we have lots of data these days, so it's a very relevant research field.
Exactly.
Yeah.
So we do research in data, but that's not the only research that we do. We also do research in algorithms. Now they're also quite important, very important. What you see there are depicting of what we call graphs. In a simple form, those are just points or nodes connected with lines. Those are fun to draw, and you can do a lot of fun things with them. But graphs are also important because they are everywhere around us. So for example, if you think about Google Map, There you have cities or places connected with roads, or if you think about social media, well, you have a lot of friends. You have friends, and there are also friends of friends and friends of friends of friends, and this also form a graph, except that graph representing social media will be pretty big, and also graph representing roads of your country, the whole road network in Europe, and these are also large graph. And you often want to do useful things about the graph, and doing things about graph tend to be what we call hard problems. So it means that when you run the algorithm, then it will go exponentially. And this is usually not what you want to do. What you want to have if you are doing something on your mobile telephone, for example, and you want to do query on your, for example, social network, then you want the results to be available in a few seconds. You do not want to wait for a whole day or a few days. So what we are looking for in the research and algorithms are typically opportunities, different kind of sub-problems, constraint situations in which problems that are normally very hard to solve turn out to be able can be solved much more efficiently. So that are also very useful for everyday life. So that was about research using computer science, using algorithms to solve problems in other domains. But the software itself is also, well, a problem. It's also a domain of its own. There are a lot of interesting things that we can research about software itself. So if you think, for example, source code is also, well, you can see that as a graph, a very complicated graph. Things inside the memory. So once you run the program, then you will see, no, you do not see it, but if you can imagine that thousands and millions of objects that are living inside the memory, they are also forming well, a graph, very complicated and quite mind-blowing. Can you tell about? I think that you're doing a lot of courses that are related with software, with research in software, right? Can you tell us a bit about those?
Yeah, so for example, I did the compiler construction course, and in the compiler construction course, we look at all the algorithms that are in use when you're building a compiler, for example. So the compiler its task is to transform your source code into machine code which can be executed, and you can do this very naively by just transforming each line of code to some machine instruction, but you can also be a bit more smart about it. For example, you could analyze, are all the variables that I have in my source code actually used, and if I don't use them, can I just remove them from the source code? Or maybe I have this tight inner loop in my algorithm, and maybe if I unroll it, instead of actually doing the loop instruction on the machine, maybe the code will be faster. So we can analyze the source code graph and make decisions about how we can generate code that might end up being quicker. And another course that I did was advanced functional programming, where we dive into type theory, and we look at how we can use the type systems of programming language to enforce that we're never in invalid states in our program, and that we catch errors that are often made by programmers much earlier, and the compiler can say, hey, you're trying to do this, but it's actually incorrect. You don't have to check this edge case. And I think that's very interesting that we can do these kind of things.
Okay, thank you. So in the research, softwares are probably all about managing complexity, right? And you look into different kind of automation, different kind of analysis, different kind of inference systems to be able to help people in writing much more reliable software, efficient software, right?
Yeah.
Okay, so that's cool. So that's research about software that we do. So let's go to the next slide. So here are the list of the courses that we offer to you. So basically, this will be the translation of things that we do. So we do research. There are 4 research groups. We do a lot of things, and we would like to transfer what we learn, what we have in our knowledge base, and this are transferred in terms of this course. So these are intended to prepare you to become to do research yourself, but also, of course, it's also intended to prepare you to get your master diploma. Can you tell us a bit about how many courses that you already did?
Yeah, so I'm almost finished with all my courses.
You're second year student.
Yeah, I'm a second year student now,
Okay.
so I still need to do 1 or 2 courses, and then I'm going to start my research. So some of the courses are mandatory, like we have let's see, it's very small. We have the concepts in program design course, the big data course, and what was the third one? Well, yeah, there are 3 courses that are mandatory, and the other ones you choose yourself, and you try to choose them within the track you want to do. So I avoided many of the algorithms courses and focused more on the software technology and programming technology courses because I found them very interesting. Yeah. Do you want me to give an example, or what?
Well, yes, please tell us a bit about courses that you did. I think that you mentioned advanced functional programming. You already said something about it, right?
Yeah.
Okay.
Yeah, but also, for example, I did technologies for learning, which is a bit different than the other stuff I did, and it focuses on all the technologies that we use to create educational software. That was something very different, but I enjoyed it a lot, though. So you can think about stuff like Blackboard or interactive tutors on the web that help people while they're learning to learn mathematics, for example, in an interactive environment, and how do we develop this kind of software to support people doing educational tasks.
All right.
Yeah.
Okay. So the thing is that you see here a lot of courses that we offer, and a student may have a different perspective, but at least from my perspective, these are all interesting courses. So the problem is perhaps a luxury problem that you need to fit this all in, well, a 2-year curriculum, and they do not really fit into 2 years curriculum. So it becomes the problem of making choices from all these interesting courses. Now, to help you a bit in making choices, so we will bring more structure into this list of courses. So Arjan already mentioned about mandatory courses, right? So let's take a look at this. If you look into, this list, the gray one are the mandatory courses, and they are intended to bring common courses for all students that do this computing science master program. And also because we have 4 research groups, and specializing in one particular research group is a good idea. It's one possible idea how you organize, how you plan your master program. But nowadays, more and more exciting research are also in the borderline between research groups. So by providing students with mandatory courses that are across different research groups, that we are trying to facilitate to push more people to do cross fields research eventually. And then you see the color, the courses that are divided into colors. You can see there blue, you can see green, you can see red and yellow. Now those are courses that are belong to certain research group. We also call it tracks here. So for example, the red courses are the courses that Arjan mainly do, so they belong to the software technology research group, whereas the yellow one are the data analysis oriented group, big data like courses, if you like. Now, let me show you the following.
I see also that there's a question by Mahmoud, may be interesting to answer.
Oh, go ahead.
He is asking, does the enrolled student have to choose his track before starting the first semester? And does he have to stick with it until the end? Or does he have the choice to switch?
No, you don't. You do not really have to stick, depending on, well, there are various factors. For example, your own situation and the schedule of the courses. But basically, once you make a plan, this is how I want to do my study, but it's not set in stone. And there are, I will show you in the next slide, and there are basically quite a lot of flexibility in the program. If you think you discover, oh, this is not really the track, it's not really the research group that I imagine it's supposed to be, then there is still the flexibility to switch to a different research group or track. Yeah. So what you see here on the slide is the structure of our program. So basically the same idea as what you saw in the previous slide. You see courses grouped in different colors. So now you see it from a different perspective. At the bottom, you see the set of mandatory courses. So we have to do 3 mandatory courses. Then you choose one of the research group, at least one. You can also choose 2, but at least one to guarantee that you will be able to do at least one research in a certain group. So you need to pick your color. And then the most important one is the one at the top, and that is the research that you yourself will do. This is your master's thesis process, called master's thesis, but I prefer to call it your research because it's to emphasize that this is the most important, the most fun part of your career here with us. So basically, you need to make your plan, to structure the courses, to make your choices according to the kind of research that you really would like to do at the end of your stay with us, at the end of your 2 years here. So there is this white space, as you see there, that's called the secondary elective courses. There are space for 4 courses. This can basically almost any courses that you can put together towards your own research. So for example, if you like, you want to specialize in the software technology, then you do more courses from the software technology group. If you want to do a combination of, for example, data-oriented, big data-oriented research in combination with probabilistic theory in combination with evolutionary computing, then you do 2 tracks, for example. You would do the track related to data, and you would also do the track related to decision support system. If you would like to do something in combination of artificial intelligence and software engineering, then you do courses in the software technology group. And filling in the white spaces with courses from artificial intelligence, for example. Good place to ask you, what were your choices here?
Yeah, so I did some secondary electives from the Game and Media Technology Master, which is a separate master program. The first elective that I did was the Optimization and Vectorization course. And this course is about getting the most amount of power out of your computer. So you have this piece of code that is doing the rendering in your game, and you want it to go from 60 frames per second to 120 frames per second. And you end up at a certain point that algorithms don't matter anymore, but that you really need to think about how does the machine work. And this also has applications in when you want to build a compiler. So this is what I found interesting as a software technology student. Like, how am I going to generate code with my compiler that's as fast as possible? And I was able to pick certain pieces out of that course that were very useful to have. So, for example, if you loop, the order in which you loop through your data structure might affect how it is cached on your CPU, and this will have speed implications. So when you do code generation, you could perhaps transform the loop to go through the data a bit differently, and then your code becomes faster. So it was interesting to do a course from another master's, but which had a lot of.
So this is a course from. This is not a course from COSC. It's not a course from Computing Science Master Program itself, right?
No, so it's from the Game and Media Technology
from
Master.
Game and Media Technology.
Yes.
So you hear it yourself. So you can also do courses from a different master program in the secondary elective course. So Arjan here did a course from Game and Media Technology. Do you happen to do any courses from AI?
No AI courses.
Okay.
No.
Okay. All right.
No.
Maybe you also want to tell us about. I know that you haven't started with your research with your master's thesis, but you did a lot of pre-research about it. Tell us a bit about it.
Yeah. So yeah, I chose to do research in the software technology group. So it first started with talking to all the researchers there. What kind of research are you doing, and do you got any interesting ideas? And now the last few weeks I've been brainstorming with my supervisor, so to say, and his name is Wouter Schwiersta. And either I'm going to do research with him about something type theory related, where we look at how we can use types to describe certain states in your application, and make sure if you, for example, make a web application, that when you're a logged in user, then you're sure that all the code you write you can only access the database when you're logged in. But if you're logged out, then the type system will say, no, you cannot do these actions. But I'm also thinking of maybe doing it at a company, which is also possible. But I'm not sure yet if I want to do it at a company. It's because you want to do something that's really research oriented. But yeah, I still need to figure it out a little bit. But,
all right.
Yeah.
All right. We have options.
Yeah, but there's lots of options.
All right.
Yeah.
Good. So we talked about a bit about master thesis. Now, in addition to those things that have been mentioned, there are also a number of additional variations. So again, here you can see the structure of our curriculum. Now we have two kinds of additional variations. The first one is called profile. And that's basically a way for you to fill in the secondary elective courses space, so the white space over there, with something thematic. So for example, if you like teaching and you would like to become a teacher, then you can do something that we call here education profile. Or if you like to do research in a multidisciplinary context, so for example, not just computing science, but also computing science applied to finance, applied to economy, something cultural, for example, then we can do complex system profile. Or if you like data a lot, then you can choose to do applied data science profile. There is also an option to do double master, which normally will take 2 times 120 EC, right? So that will be 240 EC. But you are allowed to do double master, meaning that you can get 2 diploma, but then you only need to do 180 EC, and when it comes down, you only need to do 1 master thesis, but it has to be a combined master. So those are additional possibilities that we have. Let's take a look here. Oh, it looks like it's your turn to tell about something exciting.
But I wanted to tell something about student life, because you're coming to abroad to a different country, to a different city, and I think Utrecht is a very nice place to live, very nice place to study. So the campus is around 15 minutes away from the city center. There's lots of international students here, which is a lot of fun. And you can do many study-related activities next to your study. So we have study associations at our faculty which organize events for students. So you can do you could go on a study trip, or go to a reading club, or just drink coffee with your fellow students. This is very nice. And the city is also very beautiful and nice. It's a medieval city with a nice city center with lots of bars and clubs, and you can do all sorts of activities next to your studies. Maybe you want to go rowing, or you want to do tennis. There's lots of student clubs where you can join and do these kind of activities. So
and biking?
Yeah, and biking, of course. So yeah, biking is the main form of transport in the Netherlands, especially in Utrecht. I think we have more bikes than people actually living in the city. So if you come living here, buy a bike, and yeah, it's a very nice place to live. I like it here. Yeah.
All right. Yeah. So let's go to the next slide. It's about entry requirement. All right. So obviously, if you did computer science in your bachelor, then you are admissible here. If you do exact science, mathematics, or physics, but with minor in computer science, and you are usually also admissible. If you did one in Nederland, it's called HBO Informatica. Well, usually you are admissible, but it has to be decided on individual basis depending on well, the extra courses that you did during your HBO. Proficiency in English will be needed because the courses are by default in English, and well, the entire process to apply will be, well, it's digital, and well, at the end you will get a link to proceed with application.
I also see Anastasia ask about, does everybody in Utrecht speak English? So yeah, the courses are in English, the professors speak English. And also if you go to the grocery store or something, many people in the Netherlands just speak English as a second language. So even as international students, it's very easy to get around here, I think. So
yeah, I agree with that. These are more detailed about the required base knowledge to be successful here. It's important for you to think not just in terms of admission, whether you are admitted or not, but also in terms of whether you will be successful here or not. And the end, the bottom line here, even if you are get admitted, you still have to invest 2 years of your time, which is quite significant investment. So generally, we need background in programming, and this is because well, many of the courses will deal about theory, they will deal about advanced algorithms, but at some point we want to try that out. We want to measure the performance, for example, and then you need to have ability to implement, for example, with one of those modern programming languages. You need to have some exposure to software development tools, and this is for efficiency. Just being able to programming is usually not good enough, but you need to know how to use tools. You should also be able to self-learn. So, for example, if courses require you to install, to learn certain tools, certain packages, then you are able to do that. Knowledge about standard data structures and algorithms are important. Knowledge about mathematical structures that are common in computing science, for example, things like sets, trees, graph, function relations are needed. And for the programming technology track, like what Arjan did, and we will need a more specific background, and that is background in functional programming, logic, and language and grammars. Those of you that are interested in doing the data analysis track or advanced planning decision making track, we will need probability theory and statistics. There are some questions coming in.
Well, let's see. There was one more question about why it's called computing science instead of computer science. Is there any specific reason for that, or is it just?
No specific reason. Yeah. I'm not going to go into discussion whether it's computing or computer.
I think the official diploma actually says computer sciences. That's the European code for it. But yeah, it's basically the same. Yeah.
All right. So this is to answer the questions that you may have. What if you miss some of the foundation? Now it depends. Basically where you are coming from. It's a bit difficult for international students. Basically, we try to help you, but we are also limited in the in the instruments with which we can help you. So generally, what we can do here is to offer our own bachelor courses in order to compensate for missing background. So, for example, if you miss background in algorithms or in some mathematics, then we can do a pre-master program for you. So that will be a program that is, well, it's called pre-master. So it's before you start the master program. It's a maximum of 30 EC, so it's about half a year. And in addition, we can also spend some of the elective courses to do what we call deficiency courses. So we can either do one of the two things or both of them. But the bottom line here is that basically you will be doing courses in the bachelor program, and those courses are usually given in Dutch. So this option is only open, well, for pragmatic reasons, only open for students that speak the Dutch language. And otherwise, if you are an international student, then well, then this is not really a real option. Okay, and this is the application deadline. We have two intakes, September and February. So we are talking about September 2018. Now, for February, we are basically already late for the deadline for February 2018 intake. So we are talking about February of 2019. So you can see that on the slides. Those are the next deadline. April 2018, and those are for international students. For Dutch and actually for European Union students, the deadline is June 2018. And for those looking for scholarships, then the deadline is a bit early, and that's the 1st of February 2018. All right. Okay. Can you tell us about job perspective?
Yeah, sure. Yeah, so the job perspective for the average computer science student is pretty good. Actually, so good that sometimes we're having trouble keeping people from, like, they want to start already and maybe they don't graduate. So we're trying to say, okay, first graduate and then go to the job market. I think the kind of jobs that you're gonna do, like programming, what's it called? The companies really think it's important that you have a strong background in theory, and this is really an advantage for you. It's a key advantage when you are going to look for jobs, and because you bring new insights into these companies, and you're a critical thinker, they really appreciate your academic attitude. Which you, instead of going for a job, you could also pursue your as a researcher and do a PhD. That's, perhaps you could tell a little bit more about that opportunity.
Oh,
Yeah.
yes,
Yeah.
definitely. Because this is a research-oriented master program, so basically we are training you to become a researcher. So continuing into a research career is definitely an option. Every year in the Netherlands, there are quite some amount of investment going into the research. So it means that there are always opportunities open to become a PhD student in some of the research projects. And even bigger if you look into the European size. Every year the European Union also invests quite a lot of money in research in ICT. So if you are not bound, if you are not restricted that you have to work, you have to become a PhD student in the Netherlands, then your opportunity will be even bigger. And you can apply for the position in Germany or in UK or in France. They have usually well, also quite a lot of opportunities to become a PhD student. All right.
Yeah, and there's also the possibility to start your own company, of course. And actually, I currently work at a company next to my studies who was started from the ICT entrepreneurship course at our university. So we have a master course on ICT entrepreneurship, where you're being taught how to set up a company, how to pitch your startup idea to investors, and you're actually going to talk to actual investors. So if this is a thing you want to do after your studies, start your own company, then following this course is a real opportunity to bootstrap something like that. So my bosses also did a computer science master here, and they use this course to bootstrap their company. And so this is something you can actually do, which is a lot of fun, I think.
Yeah.
So, yeah.
And also, good to mention that, well, Susan is behind the chat. Say hello, Susan. So Susan is also a student that also own a company, and that's also something that comes from this course about entrepreneurship. So there are a lot of options for you. Okay, we're almost done. So we would like to mention here, well, basically the highlights of why you would want to choose this master program of computing science at Utrecht University. Firstly, we already mentioned that this is an international program, really high quality and high value 120 EC program. It's research oriented. We do a lot of state-of-the-art research. There is also a lot of space for you to customize your program. And then there is also a good community. Maybe you can tell us a bit about the atmosphere here.
Yeah, so the atmosphere is very, so you can just walk up to a teacher, drink a cup of coffee with him, walk into his office, ask a question, and also with your fellow students you can discuss stuff. It's a very open atmosphere. It's very normal to stick around after your lecture to discuss with the professor some ideas and brainstorm a little bit. Or you can walk into some of the PhD offices and ask them some questions and brainstorm about what kind of research you want to go do. So it's very open. It's not like you're in a big lecture hall with hundreds of people. It's small groups and personal. Yeah, it's very personal. That's very nice.
Okay. Yeah. Okay. So open doors for you guys all. You can just walk in. All right. And well, we already said that in the one slide before. Excellent career perspective. So those are basically the main points why. Well, it's a good idea to choose for this master program. All right. So this will conclude our. I'm sorry, it's a different way, different direction. This will conclude our presentation of today. So it's time for question and answer. If we have those.
We have quite some questions still. So let's just start from the beginning, I guess, with maybe this one. By Nauman.
All right. So is there any research in artificial intelligence? Okay. So hello, Nauman. Let me try to answer your questions. Well, artificial intelligence is a bit broad. There is also a separate master program that is called artificial intelligence. So if that's your thing, you really want to specialize in AI, and maybe this master program AI will be a better fit. But if you want to look for a cross study, so you would like to do well, research in, for example, in data or in algorithms, but filled in with subjects among artificial intelligence, then doing computing science might be a better choice, because you still have this the free elective space, which is 4 courses, which you can fill in with courses from artificial intelligence. So the kind of artificial intelligence that we do here, mainly the agent-based kind of artificial intelligence, that's from the artificial intelligence master program, but also I think from machine learning. I think that we also do that in 1 or 2 courses. Yeah.
Let's see. So we just go from top to bottom.
That's
this
fine.
one, yeah, from Carla.
Okay, so let me read the question. On web page, it is stated that the average time to graduate is 33 months, and it's supposed to be only 24 months. How does it come? Well, I think that the information on the website is not accurate. It could be that it took numbers from many years ago. I think that recently the expected time should be much better. So we really strive to keep it like 24 months or around 24 months. One of the threats is actually that students have much too good job perspective. So they work alongside with their study, and that cause delay in the study. But basically, if people try to do their study according to the planning and the thesis according to the planning, then, well, we expect it to be around 24 months, and that's it.
Next one.
The next one, do we need a diploma or proficiency in Dutch to follow the courses in Dutch?
I think this is about the bachelor courses.
For
deficiency courses.
For the deficiency courses. Yeah. Well, that's a good question. If you already fluent in Dutch, then I don't think that we need a proof of that. It's basically coming down to whether you think that you are able to understand the explanation given during lectures. If you are able to understand those, then you're fine. Is it possible to work during studying? So there's a question by Carlos Gomez. Can you answer that? Because you have more experience about that.
Well, you can work during your studies, but it is a full-time master program, so you have to take that into account. So I actually work next to my studies as a developer. I do like 12 hours a week, and then I have the other hours to work on my studies. But that means I have to work a bit harder and more efficiently on my studies because I do want to keep on track during my studies. But yeah, it's definitely possible, but you have to be careful that you do not start slacking on courses and start to delay your studies. So yes, it is possible, but it takes some planning and some care to do it.
All right. Then we have a question from Andrea from Romania. I think it's also similar. Do you have time to work part-time during this program? You already answered that question. And can you work in the university? Can we?
Yes, you can. So, for example, you could work as a student assistant, where you assist during a bachelor or sometimes also a master course.
All right.
Or there's also Top Select Group. This is a place where you can do small jobs within the university, like, I don't know, supervise an exam or something. There is a possibility to work at the university during your studies, and after your studies, of course, as a PhD researcher. It's also at the university. Yes.
Okay, and then we have a question from Mahmoud Jabri. Is there a minimum number of EC per block to be enrolled in? Not sure. Not sure how I should interpret the question here, but normally you do 15 EC every block. So you have 1 year, which is divided into 4 quarters, 4 blocks, and every block students normally do 2 courses. There are some students that try to do 3 courses, and for some they are okay, some they are not that okay. But normally 2 courses. Of course, you can also do just 1 course every block. So that will be 7.5 EC. But then the duration of your study will also double. So instead of 2 years, then it will become 4 years, which I really do not recommend. Okay.
So there's also the question: what if I want to pursue PhD after a master program? But I think we've already covered that, but maybe we can...
We already covered that, I think. Yeah. Last questions?
Let's see. We also have... I see that some master programs in the Netherlands only take 1 year. Why does this one take 2 years and others 1 year? What's the difference in that?
Yeah. Okay, I get it now.
Yeah.
All right, so we have master program that takes 2 years and master program that take 1 year. And well, that has to do that master here is defined to be in the range of certain EC. So you can have a program that's only 60 EC, but we are offering a program that is 120 EC, and that just takes longer, so it's 2 years. Thank you.
So yeah, I think that's it for today. So yeah.
Thank you for joining. If you have questions, and you can send email to the address that are mentioned there, or if you have questions for Arjan as student ambassador, then you can send an email to to him as well.
Yeah.
All right. Thank you for watching.
Bye.